Hello guys, welcome to the DMS Online School on my YouTube channel and also TikTok and Facebook. Guys, I have a question here which came in 2018. This should be 2018 and it was sent by one of my student in my science group. So I thought of just answering it because this person has been persisting. So I said, oh, let me just answer it quickly. All right, so this one is like before study the reaction scheme below. Okay, so like they have dilute sulfuric acid, then it is acted upon by magnesium metal to form salt A plus gas B. So where is this topic coming from, or this question? It is coming from the topic acids, bases, and salts. Okay, that's where it is coming from. And what characteristic is it looking at? Reaction of acids with metals. So reactions of acids with metals. Okay, what is the general formula when an acid react with metal, especially a reactive metal? The general formula is this: if you have acid, okay, plus metal, it will give you a salt, the metal salt plus hydrogen gas. Those are the products. So like in this case, we have sulfuric acid, right, which is written like H2SO4. It will be like aqueous, but I will not do that. Plus then the metal is magnesium metal. So magnesium, the symbol is simple. If you are to go on the periodic table just to see the symbol for magnesium, so this is the symbol for magnesium, this one here. All right, you can see it. It's Mg. So that that is magnesium metal. So plus magnesium, then equals. So these reactions between acid and metals are displacement reactions. So magnesium usually displaces the hydrogen from there. So where there's hydrogen here, there will be magnesium. So it will become like magnesium. Then like Ac, this sulfate radical remain like that. Then plus this hydrogen will come out as a gas like this. Okay, so basically this is the equation here. So when part 1 they say identify substances A and B, like you identify A and B. Salt A is magnesium. So simple, right? So magnesium sulfate. Then B, gas B, it's hydrogen gas. You can see hydrogen gas. So this one will be hydrogen gas. Then like part B, they're saying magnesium sulfate is an ionic compound. Write the chemical formula of all the ions that form magnesium sulfate. Okay, so we need the ions that form magnesium sulfate, right? So it is going to be simple. So like if you were to write the ionic equation for this one, you break it. So you break it here and somewhere where here, and you cancel out the ions that will be common on both sides. All right, so if I were to cancel here, I would cancel this one and this one. All right, so yeah, but magnesium sulfate is an ionic compound. Write the chemical formula of all the ions that form magnesium sulfate. Okay, this one will be simple. The ions that form magnesium sulfate will be like you have this, all right, magnesium plus this is an ion, so it exists in aqueous, plus the other ion which is there is the sulfate, which is like this, okay, in aqueous. So this one is a radical with that minus charge there. All right, so this is the radical for sulfate there, and this is magnesium. It has a positive charge of 2. The radical sulfate has a negative charge of 2. So they are in aqueous in this case for them to give you this one, magnesium sulfate, aqueous like this. So these are the two things that combine to give you this magnesium. So these are the ions that form magnesium sulfate. Then B here, part 3 here, they're saying write a balanced chemical equation showing state symbols for the reaction between magnesium and dilute sulfuric acid. I've already even written it. So you can put it like a sulfuric acid, like SO4. Now, when they say state symbols, they want the state in which they are going to be liquid, gas, or aqueous. Like sulfuric acid, it will be in aqueous state. So the symbol for aqueous state, it is like this. Then plus this same magnesium. Magnesium is a metal, so it is in solid state. So magnesium Mg. So the state, it will be solid, represented by C like that. When you put the arrow, then in this one, magnesium sulfate, it will also be in aqueous. So magnesium sulfate like that. So aqueous also like that. Okay. Then plus C, hydrogen gas, it is a gas. So gas state is G like that. So you try to balance by comparing atoms of each element from both sides. Like hydrogen, how many atoms are here? 2. You come here, how many are they? There are 2. So hydrogen is already balanced. You come to this one, S here, sulfur, how many are they? Here 1, here they are 1. So they are balanced. You come to oxygen, how many are they? There are 4 oxygen atoms. You come here, there are how many? 4. So balanced. Magnesium, there are how many? 1 atom, here 1. So this one, it will be balanced, self-balancing like that. There's nothing that you're going to do. Then we move to the next one. So the next one, B here says name the acid that is found in sour milk. So here we found what is found in sour milk is lactic acid. All right, so for those that want online revision, serious online revision, you'll never regret in your life. Science, science is 120. Okay, so then biology, it is 60 kwacha. So once you do these, then I'm doing them on Telegram. That means when I add you to the Telegram group, you find the revision already. So we are done with the grading 10 week, especially in biology. In science, like physics, the last one we'll be doing is on simple machines, energy, and what? Simple machine, energy, and moments. So don't miss those. Then also in chemistry, we'll be doing bonding, writing chemical equations. I'll mix it with the acids, because those, they come together. So it will be mixed with the acids and what? And more concept. So you don't need to miss that, because I think I'm going to mix them in that, because those, they come in order, in that order. All right. So if you want to join my online revision, you can WhatsApp me or call me on 0977924175. All right. So this is the number. Now you can only WhatsApp me when you have the money. All right. Don't just come and make promises. You waste my time trying to talk to you. We are in business. We are doing things here. All right. So we need to use time effectively. Okay. Let's go to the other one. So the other one is here, which was like a B5. Calcium oxide is produced by heating limestone following the reaction below. Okay, so calcium oxide is this one here, all right, is produced by heating limestone. So limestone is this one here. So when you heat limestone, it will produce calcium oxide and also carbon dioxide here, all right. Then they're saying determine the relative formula mass of calcium carbonate. This one here, calcium carbonate, relative formula mass. So relative formula mass is the sum of the relative atomic mass of the atoms or elements in the compound. So you can, let me just even define it so that you understand what it is. So relative atomic mass is the sum of the relative No. I'm defining relative atomic mass when I'm supposed to be defining relative formula mass. So relative formula mass. So relative formula mass is alikunokwachisa. Relative formula mass is the total sum of the relative atomic masses of atoms in a compound. So you see, this is the what relative atomic mass, the one they're asking you here. So if you don't know the definition, how on earth will you find the answers? So first of all, you need to know the definition. So that's why I've given you the definition. Relative formula mass is the total sum of what? Relative atomic masses of atoms in a compound. So now, like you are given like calcium carbonate like that. Okay, so they want you to find the relative atomic mass of this calcium carbonate, but you must know how many atoms are in this or elements. We have calcium here, we have also carbon, we have also oxygen. So you need to know for each of these elements here, their relative atomic masses, okay, individual relative atomic mass. Where do you get them? From the periodic table. Let me show you. So if we come here, I come to the periodic table. Let me just scroll a little bit here. So see, they've given you a key here, down here. If they've given you like X, they've told you that X in the middle is atomic symbol, like the symbol of an atom or element. Then if they've put a number up here, X here, then that number represents relative atomic mass, okay? Like we come here. Let me go to calcium we are looking at. Look at calcium is here, right? Can you see calcium? Yes. So this is the symbol for calcium. This is calcium. Its symbol is here. Now, the number here, it means that's the relative atomic mass for calcium. So it's 40. So let's come here and say the relative atomic mass for calcium. We have seen that it's 40. We go for carbon, all right? So let's come again and see for carbon. Sorry. What have I done? I'm supposed to come where? Here. So for carbon is here. So carbon is this one here, carbon. The symbol is C. So this number up 12 here is the relative atomic mass for carbon. So come and put it here, 12. Then we'll go for oxygen as well. Okay, when you come for oxygen is here. Oxygen, the symbol is O. Then the relative atomic mass is 16. So you come quickly there, you say 16. Okay. Then now, when you say relative formula mass is the total sum is adding now. The total sum of the relative atomic masses of atoms in the compound. So you add these relative atomic masses of these atoms in this compound. Their total will be the relative formula mass. So you say, okay, equals. So for carbon, since you have only one carbon atom here, its relative atomic mass 40, you write it like that. Then you say plus. For carbon, you only have one carbon. Its relative atomic mass is 12. You write it as it is 12. Then you say plus. For oxygen, there are 3. There is a 3 down here, meaning the oxygen atoms are 3. So you write 3 oxygen atoms times the relative atomic mass for oxygen there, 16. Okay? Then what do? You add, like, first of all, you multiply 3 times 16, right? So let me just do this. 16 times 3. What are we going to get? that one 18, carry 1, that one it will be 4 plus 1, 48. So it's like we are adding 40 plus 12 plus 48. So let me just use my calculator there so that I will not take much of the time in doing this. So I'll just say 40 plus 12 plus 48. I'm getting 100, right? So here I'm getting, oh, sorry. Look, it's 100, not 400. Where am I going? So it will be 400, 100, I mean, 100. So it has no units. So you are going to say, therefore, uh, relative, this is the symbol we use, relative formula. No. Relative formula mass of calcium carbonate is equal to 100. So this is being logical. You have answered 2 marks. Then here, let me see if I created space here. No. Okay. There were more marks here. I didn't capture that one. But here they're saying determine the mass of calcium oxide produced if 400.0 gram of calcium carbonate is decomposed fully. So they're telling you to say, find the mass of calcium oxide, this one here, that will be produced if here you have 400 of calcium carbonate. Okay, let me put it like this. So if you have 400 grams, they're saying you have 400 grams of calcium, you break it. Okay, then they're saying how much is it going to produce here? You say X, just say X. But before you say X, you need to balance the equation. So let me just write it here properly. So I have calcium carbonate that is being broken down or decomposed to calcium oxide plus carbon dioxide. So if I try to balance this equation, I will discover that it is already balanced because calcium is 1 here, even here 1. Then carbon is 1, even here it's 1. Oxygen here, there are 3. Here 1 plus this. Oh, sorry, look at the way I've written carbon dioxide. Carbon dioxide here is supposed to be 2. So 2 here. So oxygen here, this 1 here plus this 2, there will be 3. So meaning it is balanced. So this equation is balanced already. Now they've told you to say, all right, they've given you, they're saying determine the mass of calcium oxide produced if 400.0 grams of calcium carbonate is decomposed fully. So if it is called decomposed fully, meaning it is actually going to be used, everything will be used to produce this and that. So now, so you have 400 grams that is being decomposed. So they want for calcium oxide. How much will be produced? You don't know. You say X. Okay. Now, this is a very, very simple. So you say, okay, at microscopic level, at equation level, okay, at the stoichiometric level. In short, let me just rub this one first. I begin building from stoichiometric level. So if it is balanced like this at the stoichiometric level, what amount has decomposed? What amount of calcium has decomposed to give you calcium oxide and the carbon dioxide? What amount of calcium carbonate has decomposed to give you calcium oxide plus the carbon dioxide? Okay, the amount is 100. 100. This 100 relative formula mass is the one that has decomposed at the stoichiometric level to give you how much of carbon dioxide. Again, you are going to total for carbon dioxide to find its relative atomic mass. So if this is 40 and this is oxygen is 16, right? So you are just going to say, okay, 40 plus 16. All right, what are we getting? 56. All right, so meaning at microscopic level, if you have 100 of calcium carbonate, it will produce 56. Okay, 56 of calcium oxide. Now, if now someone just came and said, okay, now we have given you 400 of calcium carbonate grams, how much is it going to produce? for calcium oxide, you put X, as simple as that. Then you cross it, multiply. Okay, so you say 100 times X, it will just give you like 100X equals, then 400 times 56. Let's just do that. 400 times 56. What are we getting? 22,400. Okay, so we have 22,400. Now, because of G here, we put grams. Now, we want to know what the value of X is, because that value of X represents the mass of calcium oxide. So, let me just copy this one here. So, it is 100X, which is going to be equal to 22,400 grams. So, I want to know X, so I'll divide by 100, even here quickly by 100, right? So that this one and this one will go. Then this one and this one will go. So X will be equal to like 2, 224 grams. So meaning that will be the mass of what? Calcium oxide. So you say therefore 224 gram of. Now, because they've written up to, they've put a point here, even you add it, because here they're using how many significant figures? 1, 2, 3, 4. Even you here use it, so that you move. That is how scientists move. You follow the order. So say 224.0 gram of calcium oxide will be produced. Okay, you see. So this is one method that I've shown, okay, based on understanding stoichiometry. But if you want, you can solve it in another method that I'm going to show. So let me show another method, right? So another method is first to find the. Okay, let me just use this thing here to wrap everything. So the other method to use is to get the same formula here. Okay, is first to find the number of moles, mole to mole ratio. You find the number of moles of calcium carbonate in that 400. So you know number of moles is given by mass over molar mass. And if you look at the mass, this is the mass we are provided, okay? So which is 400 or gram over. Then if you look at the molar mass for calcium, we already found it to be 100, okay? 100. That was relative atomic mass. So relative atomic mass equals to molar mass, okay? The mass for 1 mole, okay? That's how it is. So it is 100 gram per mole. So like you find that this one and that one usually cancels. Then 100 into 400, it will be 4, all right? So it will be 4 moles. So it means that you have, in this 400, there are 4 moles of calcium carbonate. So you have 4 moles of calcium carbonate. Okay. Now, having found that, you get the same formula. You say, okay, I am given calcium carbonate that is being broken into calcium oxide plus carbon dioxide. Then what you're going to say is this. You are going to say, okay, let me know in this balanced equation, like it is, you are using another formula, mole to mole relationship. I have got 1 mole of calcium carbonate and 1 mole of calcium oxide. So you say always stoichiometrically, if you have 1 mole of calcium carbonate reacting or decomposing, it produces 1 mole of calcium oxide. Now I'm given 400. I want to know how many moles of calcium are there. There are how many? There are 4 moles of calcium. So you say, how about if I'm given 4 mole of calcium? How much am I going to find for calcium oxide? X. You put X. Then you cross multiply X times 1. It will be X equals. Then 4 times 1. It will be 4. All right. So meaning X is 4, meaning in 4 moles, if you are given 1 more, it is giving you 1 more. 4 more, 4 moles as well. Now that you know 4 moles of calcium oxide, you can find the mass, because the question is saying mass. So what formula will you use? The same. So you say, okay, I want to know the mass of calcium using this formula. Number of moles is equal to mass over molar mass. Now you make mass the subject of the formula, which will be mass is equal to number of moles times molar mass. So you say equals, so number of moles you already know, number of moles of calcium oxide is 4, you put 4 here, times molar mass is molar mass of calcium, we found it, which was 56. So 56. Now you are going to multiply 4 times 56. So we are going to get our calculator very quickly. So let's get our calculator and then do like y is 4 times 56. We are going to get 224. The same answer that we found. 224 F grams. All right. So you see, this is how it is found. So let's move. So here, give one natural and one artificial use of gas produced in the reaction above. So one natural use of the gas produced there like give one natural and one artificial use of the gas produced in the reaction above. So one natural use of oxygen, one natural use of oxygen, I mean hydrogen, yeah. So hydrogen, what natural use of nitrogen do we have? Nitrogen we have. It is this reaction we are talking about, this gas, carbon dioxide, one natural use. So carbon dioxide is used in photosynthesis. Right? So you say carbon dioxide is used in photosynthesis. Oh, sorry, this is not photosynthesis. In photosynthesis. Okay, then artificial use, it has so many artificial use, carbon dioxide, right? One of them is in fire extinguishers, in fire extinguishers, extinguishers. Also, in as a refrigerant, as a refrigerant gas, I think. This spelling, guys, I don't know the spelling. I know it, but I've forgotten it. A long time I wrote it, refrigerant. Okay. It is also used also in carbonated drinks. So this is how this question was supposed to be. So yeah, for now, guys, bye and see you in the other video that I'm going to upload.